Hi boys and girls, today we're going to be doing lesson 3 of unit 11. It's called geometric sequences. I know in the past lessons you've been learning about arithmetic sequences, so today we're going to be learning about geometric sequences. Starting off with the do now, it says, what pattern do you see in the sequence? We have 1, 3, 9, 27. So my numbers are getting bigger, so I know it's either going to be adding or multiplication. So if I try out adding right here and I say, okay, well, to get from 1 to 3, I would have to add 2. But if I add 2 to 3, now that next number should be 5, and it's not, it's a 9. So it's not addition, it must be multiplication. Well, let's check it out. 1 to 3, I would have to multiply by 3. Let's try that number again. 3 times 3. Well, 3 times 3 is 9. 9 times 3 would get me to 27. So that number has to be consistent. It has to be the same number over and over again in the same operation. So we're multiplying by 3 each time. So let's write that. Multiplying by 3. That's the pattern that we're seeing. Multiplying by 3, and let's just add each time. So now it says using this pattern, they want us to state the next 3 terms. Well, we started off with 1, 3, 9, 27. They gave us that. They want to know the next 3 spots, or the next 3 numbers. So I'm just going to set myself up here. Well, we already figured out up here we have to multiply by 3. So we multiplied by 3, we multiplied by 3, we multiplied by 3. We're going to just keep going. 27 times 3. Let's test it out. 27 times 3, we get 81. You take 81 and you multiply by 3. Oops. We get 243, and then you take 243 and you multiply by 3. And you get 729. So these would be the next 3 terms. So we can even just say 81, 243, and 729 are the next 3 terms. We just followed that pattern all the way through until we found what we needed. Oops. All right, so let's take a look at what a geometric sequence is. I'm going to highlight a geometric sequence. Is a sequence in which you multiply, just like we did in the do now, the same value, so we multiply the same value over and over to get from one term to the next. In the do now, we multiplied by 3 over and over to get to the next term. Just to make it a little bit easier, they're not always going to tell us the next 3 terms. They might tell us to find the 30th term, the 100th term, the 6th term. We don't really know. So what we can do is we can always use this formula that they give us to find any term. So this is our formula. It's a sub n equals a sub 1 times r raised to the n minus 1. So let's just talk about those pieces. Some of them are very similar to the one that you've seen in the arithmetic sequence. We have a sub n right here. That is the nth term. It's usually what we're going to be looking for, so we can even write that on the side. What we don't know, or what we are usually looking for. A sub 1 is going to be the first term. N is going to be the position of the nth term. I'm going to highlight that. Position of the nth term. For example, if they ask us to find the 9th term of something, or a sub 9, you could see it that way too. What you're going to know, or have to know, that n is that number. So it's the 9th term, n is going to be 9. If it's the 100th term, n is going to be 100. If it's the 7th term, n is going to be 7. Okay, and then our last piece is r, which is our new piece. It's the common ratio. So I know in past lessons you learned about d, which was the common difference. We're now going to talk about r, which is the common ratio. And the common ratio is going to be what we multiply by. So if we just look back at the do now, we multiplied by 3 each time. So our common ratio for the do now would have been 3. So we could have said like R equals 3 in that scenario. Let's add that up here. R equals 3 because that's the common ratio. Just a little extra note. All right, let's find out how to find the common ratio. To find the common ratio, because it's not always going to be so easy. I know the do now we were kind of able to figure out, oh, multiply by 3. If it's not that easy, or even if the do now wasn't that easy, here's a simple way for you. To find the common ratio, which is what we multiply by, we take any two consecutive terms. Consecutive means one after another. And we divide right to left. We divide right over left. This right here. Okay, consecutive means one after another. So let's just do an example and you'll understand what I mean. Find the common ratio of each. So what we're going to do is we're going to use that formula that the directions gave us. We're going to divide right over left. So I'm going to write that. Common ratio is represented by the letter R, and we divide right over left. You can take any two consecutive numbers. So I'm going to just start for the first two. So for example, I could have done 4, which is on the right. I'm going to take 1 and 4. 4 is on the right. I divide it by the one on the left. It's kind of like working backwards. I divide 4, divided by 1, we get 4. Okay, those are not the only two I could have used. I could have used another two. Let's say I wanted to try 16 and 4. I could have done the same thing. Those two are consecutive with each other. I could have done, just as another example, I could have done 16 and 4. So I would have done 16 is on the right, divided by 4. 16 divided by 4 is 4. So either way, I still get the same common ratio. I still get the same R value. So at the end, we just want to write R equals 4. That's how we represent the common ratio. So let's take a look at B. I'm going to do the same thing. Divide right over left. So common ratio is represented by R. We divide right over left. So any two numbers you want. For this case, I'm going to take, I don't know, let's do 9 and 27. We got 9 is on the right, divided by 27. So I type that in my calculator. Nine divided by 27. I get this long decimal, repeating decimal. We don't want it in that form because we don't want to have to use that long decimal. So we hit math, enter, enter. And we get 1/3. If you wanted to, right from the beginning, you could have used the alpha y equals function. So we hit alpha y equals, you hit enter, and then you could have put right in the beginning like 9 over 27. Enter, and it will simplify the fraction for you in the calculator. So either way, whatever you feel most comfortable with, but it comes out to 1/3. So I write that down on my paper, and then I can just put R equals 1/3. Okay, if you wanted to ever check to see if you did your common ratio correctly, what you do is go back to the original sequence. Well, by saying this is the common ratio, what that means is you're multiplying by 1/3. Well, 81 times 1/3, if you do that in the calculator, you're going to get 27. 27 times 1/3, you're going to get to 9. 9 times 1/3, you're going to get to 3. Same thing if I wanted to check A. Well, we said our common ratio was 4. 1 times 4 is 4. 4 times 4, 16. 16 times 4, 64. Okay? It's just like a little formula for you to help you figure out what the common ratio is. Taking a look at the next page. Example 2. Given the geometric sequence, I'm going to highlight that right away. That's our new vocab for today. Geometric sequence, -2, -4, -8, and so on. They want us to find A sub n. Okay, so you have learned that A sub n is really the same as the 7th term. And you could also see it as f of 7, both ways. Okay, but that's what we're going to be looking for. That's what they want us to find. So geometric, we learned on the previous page in our notes, geometric means multiplication. Arithmetic meant we were going to either add or subtract. Geometric means that we were going to multiply. So I'm going to write geometric formula. I'm going to write that formula from the previous page. It's also right up here, so you can always reference it there. A sub n equals A sub 1 times r raised to the n minus 1. So there's 3 pieces that we need for our formula. We need to figure out what the n value is. We need to figure out what a sub 1 is, which is the first term, and we need to figure out what r is. So those are the 3 pieces that I'm going to list on the side. N, a sub 1, and r. N is what we're looking for. It's the position we are looking for. Position of the nth term. Well, they want us to find a sub 7, which is the 7th term. So your n is just going to be this little number down here. So n is going to be 7. A sub 1 is the first term. Well, my first term in my list is -2. This is my first term. So I'm just going to put -2. Now the r is the common ratio that we just learned how to find on the previous page. So the common ratio, we're figuring out what we're multiplying up here. What are we multiplying to get from -2 to -4? Well, we just figured out I can do right divided by left. I always just take the first two. So -4 is on the right, divided by -2. When I divide those two out, -4 divided by -2, you get a +2. So that would be your r. Now I go into my formula. I have a. I'm going to plug in for n. Instead of n, I'm going to write 7 equals a sub 1, or the first term, is a -2. I'm going to put that in parentheses. Times, I'm going to do another set of parentheses, the r, which we just figured out was 2, raised to the n, which was 7, minus 1. Now what you can do is just plug this whole thing in the calculator at once. So a sub 7, we're going to just copy that down, equals, and I'll show you how to put in the calculator. I'm going to just put this piece in the calculator. So parentheses, -2, close parentheses, open your parentheses again, 2, raised, so that little caret key, to the 7 minus 1. Make sure that 7 minus 1 is all raised. Hit enter, and you get -128. Move this. So this would be my final answer. A sub 7 equals -128. The other way we can say this is the 7th term is -128. There's 2 ways to say it. Okay. So, I mean, I could have sat here and tried to figure out, okay, well, -2 times 2 is a -4, and then I keep going until I get to the 7th number, but it's not always going to the 7th spot, I should say. It's not always going to be that simple, and that's why we give you this formula to use. Okay, this is extremely important. You are given it on the reference table, so you don't need to memorize it, but you do need to know that the geometric means that is when we're multiplying. Geometric sequencing. Example 3. What is the 9th term? I'm going to highlight that. That's what we're looking to find of the geometric sequence 1, 4, 16, and so on. I'm going to also highlight geometric sequence. We just talked about that. That means I'm multiplying. Multiplication. And I'm finding the 9th term. So another way I can write that is a sub 9. I'm going to write my formula. a sub n. My geometric formula equals a sub 1 times r raised to the n minus 1. My three pieces that I need to pull out: my n, my a sub 1, my r. My n is what I'm looking for. Well, I'm looking for the 9th term, so my n is going to be 9. Again, position you are looking for. The a sub 1 is the first term. Well, my first term in my list is 1. So I'm going to put a sub 1 equals 1. My r stands for common ratio, which means what we're multiplying by. So you can look up here to try to figure out what you're multiplying by, or you can do our little trick, right over left, right divided by left. So I take 4 and I divide it by the previous number. 4 divided by 1 is 4, so my common ratio, what I'm multiplying by, is 4. And you could always check, well, to get from 1 to 4, I multiply by 4. 4 to 16, multiply by 4. Okay, so it works out. I did it correctly. Now we just plug in. So again, my three pieces that I'm going to plug in. A, n is going to be 9, equals a sub 1. I already wrote it down. My first term is 1, in parentheses, times my r, which we figured out was 4. It's what we're multiplying by, raised to the n, which was 9, minus 1. Type this all in the calculator. 1 in parentheses times 4 in parentheses, and then raised to the 9 minus 1. Make sure again that 9 minus 1 is all raised as an exponent. When you type that in, you get a to the 9 equals 65,536. That would be my final answer. You could also, again, write it and say the 9th term is 65,536. You should always get used to going back to the question and see how they ask it, and then you could always restate it as however they ask it. All right, example 4. Consider the pattern of squares below. So let's just look at the squares for a second. The first one has 2. So that would be like my first term. Or really, we know the first term can be written as a sub 1. Then this one has 4 squares. I'm just going to put a 4 up here. That would be like my second term, a sub 2. And this one has 1, 2, 3, 4, 5, 6, 7, 8. That would be a sub 3, or my third term. They want to know how many squares will be in the 10th pattern. The 10th pattern is like saying the 10th term, or a sub 10. So, I need to look at my pattern. It goes 2, 4, and then 8, right, from my squares. So to get from 2 to 4, I don't really know if it's geometric or arithmetic yet. They didn't tell me. So I need to figure out, well, am I multiplying in this pattern? Or am I adding in this pattern? Okay, if I try to add, okay, 2 plus 2 is 4, but then if I add 2 to 4, I'm not going to get 8. So let's try multiplication. 2 times 2 is 4. 4 times 2 does get me to 8. All right, so because I'm multiplying, that means I'm going to be using my geometric formula. So I'm going to write geometric because we are multiplying. You can even say multiplying by 2 if you want to add it. So I'm going to write the formula. Same as up above, a sub n equals a sub 1 times r raised to the n minus 1. My three pieces I need to pull out, my n, my a sub 1, my r. My n is what I'm looking for, what I'm trying to solve for. Well, I'm trying to solve for this 10th term, so my n is going to be 10. A sub 1 is the first term. Well, I can look up here. My first term had 2 squares, so my first term is 2. And my r is my common ratio. What I'm multiplying by, well, I figured it out over here. I'm multiplying by 2. The other trick I could have done is go right divided by left. So I pick any two numbers next to each other. I'm going to do the 4 and the 2. So I do my 4 divided by 2. I get my common ratio of 2. Now I just plug in a, my n is 10, equals a sub 1, which I wrote down over here was 2, in parentheses, times r, which I figured out was 2, that's what we're multiplying by, raised to the n, which was 10, minus 1. Plug it in the calculator. A sub 10 equals 1,024. So again, I can keep it like this, but they really ask how many squares will be in the 10th pattern, so I should restate it. In their words, the 10th pattern will have 1,024 squares. These are my final answers. They mean the same thing. Okay, next page. Find the fourth term of the geometric sequence, 459, 153, 51, and so on. So they want me to find the fourth term. So I'm going to write fourth, and I'm also going to write a sub 4. Okay, those are the different ways we'll see it. Of the geometric sequence, huge keyword. Geometric sequence means I'm multiplying, so it's multiplication. A little different because my numbers are going down. Okay, they're decreasing. But that means I can still multiply. I just would have to be multiplying by a number less than 1. So, geometric sequence. They told me it's geometric sequence, so I'm automatically going to write geometric and write down my formula. That's in my notes and at the top of the page. A sub n equals a sub 1 times r raised to the n minus 1. I'm going to pull out my 3 pieces. N, a sub 1, r. N is going to be what we're looking for. Well, we're looking for the fourth term, so n is 4. A sub 1, the first term. Well, my first term in the list, in the sequence, is 459. My r is what we're multiplying by. This is what I was talking about earlier, where it's not so easy to figure out all the time. 459, I'm trying to figure out what I'm multiplying by to get to 153. So let's just use our trick. That's the easiest way. So I'm going to do, I'm going to do right over left. Let's take the first 2 numbers. So my right number is 153 divided by the one on the left, 459. When I put that in the calculator, it simplifies to 1/3. So now I just go and I plug in. A sub n, well, I'm going to do a sub 4, n is 4, equals a sub 1. Well, a sub 1 is 459. I'm going to put that in parentheses. My r, I just figured out, is 1/3 in parentheses, raised to the n, which is 4, minus 1. You type that all in the calculator, and you get a sub 4 equals 17. So again, I can list it like this, or the fourth term is 17. Either way is fine. Okay, so same pattern as before, just a little different with the common ratio. It comes out to a fraction, but you still follow the same exact steps. And you can always check up here and say, okay, well, 459 times 1/3 should get me 153, and just keep trying it to make sure the pattern is correct, or the ratio is correct. Example 6. What is the formula for the nth term of the sequence? So now they say the nth term. They don't give us like a 9th term or a 5th term or a 4th term. They say the nth term. So instead of writing it like we did up here, a sub 4, we're just going to write a sub n. In the sequence 54, 18, 6. So I need to decide, is it geometric? Is it arithmetic? They didn't tell me. Well, I can sit here and try to figure out what number to get from 54 to 18. If I subtract those two, I end up getting 36. So what that means is if I subtract 36 here, I could get 18. But then if I subtract 18 minus 36, not going to get me to 6. So it can't be adding or subtracting. So it can't be arithmetic. It must be geometric. The other way you can figure that out is look at the formulas. Okay? They look like a geometric formula, which is a sub n equals a sub 1 times r n minus 1. So our three pieces, we need n, we need a sub 1, and we need r. Well, we were looking at n in the previous examples. It was whatever they told us to find, right? The 4th term. Well, this says to find the nth term. Well, so n, we don't really know a number, we just know it's n. So I really don't even need it. Just keep it as a sub n. My a sub 1 is my first term. Well, my first term is 54. And my r is my common ratio. What am I multiplying by? I didn't figure that out yet, so I got to do that. Right over left. Let's do 18 over 54. It's like working backwards. 18 divided by 54. I get 0.3 repeating. So I could do alpha y equals, or I can hit math, enter, enter. I get 1/3 again. All right, so let's plug in. A sub 1 is 54. Parentheses. 1/3. Raised to the n, which stays at n because I don't know it, minus 1. So now if you look at your choices, this is what we got. And then that matches choice 4. So choice 4 is correct. You could have also started eliminating in the beginning. Okay, I know my formula has to have an n minus 1, so I could have got rid of 1 and 3 because they only have n. They don't have n minus 1. And then I would have had to choose, is it 6 the first term, or is it 54 the first term? Well, looking at my choices, 54 is the first term, and that's what I start with in my formula. Okay, so just another strategy you could have used to make sure that choice 4 was correct. Looking at the closure real quick, it says a bracket for a basketball tournament is shown below. How many teams are in round 1? So you're going to look here for round 1. Well, if you count them up, there's 8 teams. How many teams are in round 2? Well, if I look here, round 2 has 4 teams. There's 4 different names. How many teams are in round 3? Well, I'm left with 2. What is the common ratio? So you're going to have to know the difference between a common difference and a common ratio. Today we talked about common ratios. Common ratio is what we are multiplying by. It's our r value. Okay, we did that before. We did right over left. So if my sequence was 8, 4, 2, or my 3 numbers that I had, I can take the 4 and the 8 and go right over left. So 4 divided by 8, you should get 0.5 or 1/2. Either one is acceptable. And I could always check, well, what's happening with my teams is the number is getting cut in half. It's being multiplied by 1/2 each time. Okay? That is it for this lesson. Your job is to take the notes along with the video that we just did, and then, of course, try the homework questions on your own. Remember that the common ratio is r. Okay, if they're asking you to find something, like a sub n, okay, that means it's the 9th term. And then the bottom one is an example with pictures, okay? So just try your best, and we'll see you on the next video.